So we are starting with alkanol, IUPAC nomenclature of alkanol. The general formula of alkanol or alcohol is CN A2N plus 1 OH. That's the general formula. Why the functional group? The functional group is COH. Let's take note of that. So let's see what are the members. So the first member of alkanol, we call it methanol. Methanol, where the number of carbon atoms is equal to 1 next. So let's substitute. So the molecular formula of methanol is equal to C1H 2 times 1 2 plus 2 1 3 OH. That is methanol. And this is the structure. What is methanol? 2. We have ethanol. Ethanol. It is written as C2 when N is equal to 2. Put 2 here. C2 H2 times 2 4 plus 1 5. C2 H5 OH. And structurally it is written as this. We have hydrogen here, hydrogen here, hydrogen here, hydrogen here, hydrogen is 5, then followed by OH. That's the structure. That's the structure. 3. We have propanol. Propanol or propan1 or. So this one is C3H7, then OH, when N is equal to 3. So if you want to draw it structurally, you 1, 2, 3. Distribute hydrogen. OH, and so on and so forth. So 4. What's the formula for butanol? The molecular formula will be C4H9OH. 5. Let me say decanol. That is C10H21OH. 6. Let's see octadecanol. Octadecanol. That is 18. Octa 8, decanol 10. Dec 10, that is 18. Octadecanol. So we see 18 H 37 OH. OH. What of ecosanol? Ecosanol. That is 20 C20 H41 OH and etc. So let's see H. Let's see if the position of all OH is altered. 1, 2, 3. Then OH is here. How do we name this? How do we name this? So all is on carbon 2. If you count from left to right or right to left. From left to right, 1, 2, 3. From the right to left, 1, 2, 3. You can see all is either order or is attached to carbon 2. So 2 will be etan 2 or H2 or. Number 9 now. We have CCC. We have OH here. We have another OH. We have hydrogen, 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 hydrogen. So this one is a F12-diol. You can see all attached to carbon 1, another hull on carbon 2. So it will be 2 or diol. F12-diol. This is known as a glycol in chemistry. This is used as antifreeze in cold region to prevent knocking of engine. So we call it a petrol additive. So that is a glycol. F12-diol. So we have 3. We have 1, 2, 3. OH here, OH here, another OH here. So we have hydrogen here, hydrogen here, hydrogen here, hydrogen here, hydrogen here. On carbon 1 or on carbon 2, another on carbon 3. So we have, and the parent name is prop. This is 1, 2, 3. That is propan. 1, 2, 3. Triol. 1 hull on carbon 1, another hull on carbon 2, another hull on carbon 3. So 1, 2, 3, making 3 hull. So propan 1, 2, 3 triol. This is known as a glycerol. That's the formula for glycerol. Propan 1, 2, 3 triol. So number 11. We have 1, 2, 3. We have methyl here. We have OH here. We have another OH here. We have another OH. You can see if you count from left to right to right, this is 1, 2, 3. Methyl attached to carbon 2, or on carbon 1 and another hull on carbon 3. So it will be 2 methyl propan 1, 3 propan 1, 3 diol. 2 methyl of carbon 2, so 2 methyl propan 1, 3 diol. So 1 and 3, or that is what we have. Number 12. Let's say you are given this name. Just note. Let me call it A and call it B. They say write down the structure of 2 methyl propan 1, 3 diol. So you start with the parent name, that is 1, 2, 3, or on carbon 1, you can say all here, another hull on carbon 3, that is it. Then you have methyl on carbon 2, this is methyl, A3 is methyl. Then you complete with hydrogen, complete it with hydrogen. So that's the structure. You can give it the name. That's the structure. Please take note. That's how to name alkanol. It's very easy and straightforward. Please take note of that. Look at alkanoic acid, the one we call carboxylic acid. We call it carboxylic acid. And the functional group is, you still remember? COOH. That's the functional group. So the general formula of alkanoic acid is CnA2n plus 1 COOH. Please take note of that. CnA2n plus 1 COOH. So the first member, we call it methanoic acid. Methanoic acid. The one we call formic acid. Formic acid. Call it formic acid. Obtained from ants and bee sting. So that is a formic acid. What's the molecular formula? The molecular formula, apply the formula. That is the when N is equal to. Be careful here. When you are using methanoic acid, you know, carbon is already there. So this one must be 0. So when they say methanoic acid, this one is 1 already. So N must start with N when N is equal to 0. Always remember that when you are using the formula, when N is equal to 0. So methanoic acid will now be 0 here is gone. It will remain 8. 2 times 0 plus 1. 2 times 0, 1 plus 1. And 2 times 0, 0 plus 1, 1. Then HCOOH. Please take note of that. So structurally, you have HC double bond OH. Is the structure of methanoic acid. So be careful. You want to draw the structure of ethanoic acid. Ethanoic acid. It must be where N is 1. That is, N is equal to 1 here. Don't use where E, because of the fact that E is 2. F is 2. Don't use that, because 1 carbon is already here. So if you use N is equal to 1, so ethanoic acid will now be the molecular formula ethanoic acid. This one called acetic acid. Acetic acid, which is obtained from vinegar. That is the source, acetic acid. So it's equal to the molecular formula will be C. This is 1 2 times 1 2 plus 1 3 Ca3 COOH. So structurally, C, we have hydrogen here, hydrogen here, hydrogen, another C here, double bond OH. So this is known as a ethanoic acid. So let's draw propanoic. Let's draw the formula for propanoic acid. Propanoic acid, meaning where N, you put where N is equal to 2. Be careful. Where N is equal to 2 here, you have C2, 2 times 2, 4 plus 1, H, COOH. You can see, making 3. The number of carbon is now 3. The number of carbon is now 2, F. The number of carbon here is 1. Take note of that. So you can draw the structure of this. Still the same thing. 1, 2, 3. Hydrogen here, hydrogen here, hydrogen here, hydrogen here, hydrogen here. Then double bond, single bond, H. That's the structure of propanoic acid. Number 4. So what of butanoic acid? Butanoic acid. For butanoic acid, we are going to use is equals to C, where the N is equals to 3. So use the formula C3, H2 times 3, 6 plus 1, 7, then COOH. Structurally, 1, 2, 3. We have hydrogen here, hydrogen here, hydrogen here, hydrogen here, hydrogen here, hydrogen here, hydrogen here. Then this is butanoic 4. So this one will be double bond OH. That's the structure of butanoic acid. So 5. So let's see. You can see the oic. There are the two functional groups are here, and this is earth. So if you want to name this is a ethane or earth 1, 2. Oic is on carbon 1 and carbon 2. Call it earth 1, 2 dioic acid. It's a dicarboxylic acid. We call it a dicarboxylic acid. It has two functional groups. Repeated. You can see one here, another one here. So call it H1 to dioic acid. This one is known as oxalic acid. In chemistry, we call it oxalic acid, which you can write as how many hydrogen? 2. Hydrogen is 2. How many carbon? Carbon is 2. How many oxygen? 4. H2C2O4. That is oxalic acid. Please take note of that. That is H1 to dioic acid. 6. Let's see 1, 2, 3, 4. Like this. There are two functional groups here, two different functional groups. 1, 2, 3, 4. 1, 2, 3, 4. Two different functional groups. We have alkane and alkanoic acid. So how do we combine this? In their priority, this one comes before in. So be careful. So if you want to count this, you start from here. So the 1, 2, in is on carbon 2. And the parent name is 1, 2, 3, 4. So we have seen boots. In is on carbon 2. Boot 2, that is on carbon 2. Oic on carbon 1. So you will just, instead of putting butanoic acid, so just add in here, add it to, so we call it boot 2 enoic acid. So this is boot 2 enoic acid. This E represents in here, alkane group. That's what called boot 2 enoic acid. Please take note of that. Take note of that. Is 6. Let's say you have 1, 2, 3, 4. Something like this. So this one will be, you must always start from here. So this is 1, 2, 3. Methyl after this is carbon 1, carbon 2, carbon 3, carbon 4. So methyl attached to carbon 3. And the parent name is, you can see 1, 2, 3, 4. That is butanoic acid. So to name this now, methyl attached to carbon 3. So it will be 3 methyl, 3 methyl butanoic acid. 2 methyl, 3 methyl butanoic acid. Please take note of that. Number 8. Let's say you have something like this, and you have the oil here. You have something like this. This is hydrogen, 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 hydrogen. Be careful here. So count. The count from here to here. 1, 2, 3, 4. So the longest 1, 2, 3, 4. The same thing. Either you come from here to the right, from right to the left, or from the left to the right. Always start from the oic. So 1, 2, 3, 4. So that is a butanoic acid. But this alkyl group is ethyl that has to carbon 2. That has to carbon 2 here. So the name will now be 2-ethyl. The name will be 2-ethyl butanoic acid. 2-methyl butanoic acid. 2-ethyl butanoic acid, because this is a C2H5. This one is a C2H5. Is the one attached. You cannot count from here to here. You start from the functional group in this case. So that is how to name. Let's see. Question 0.25 mole of a carboxylic acid. 0.2 mole of it contains So this is the question. Record that 1 mole of a compound is equal to its molar mass. So this is not the molar mass. We have to look for the molar mass. So you can say 0.25 mole of the acid is equivalent to 22 grams of the acid. Therefore, you look for 1 mole because you are looking for molar mass. So it will be 1 times 23 divided by 0.25. It will give us 88 grams. So what is the general formula of carboxylic? CnA2n plus 1 COOH is equals to the molar mass. So you use this as molecular formula. That's the general formula. So this one will be 12n plus 2n plus 1. Mass number of hydrogen is 1. So plus carbon 12, oxygen 16, another oxygen 16, another hydrogen 1 is equals to 88. So 14n plus 38, this is 13, this is 32, 32 plus 13, that is 45. This is 30, this 32 plus 14, that is 46. 46 is equals to 88. 14n is equals to 88 minus 46. This one is 42. 42, that is 14n. N9 is equals to 42 divided by 14. And now we now give you something like 3. N is equals to 3. So where n is equals to 3, then I complete it here. Where n is equals to 3, so from the formula, put the formula here. So the molecular formula of the acid will be C3H 2 times 3 6 plus 1 7 COOH, and the name will be, remember, 3 carbon and another carbon making 4. So this one is known as butanoic acid. So it's butanoic acid. That is question number 1. Please take note of that. Let's consider alkana or aldehyde. So the functional group here, if you still remember, we have this is the functional group, and the general formula of alkana is CnA2n plus 1 COH. Let's take note of that. The first member, we call it a methanol. Methanol. And remember, one carbon is already here, so you can't say, if you want to write the formula, you can't say when n is equal to 1. It must be when n is equal to 0. Take note of that. So we say when n is equal to 0. So when you put 0 here, this one is going 0 here. Then 0 is 0 plus 1. It will remain 1 hydrogen, then COH. So it is written out or CHO. That we call it CHO. I prefer CHO. So CHO. So this is written out C O then H. CHO. That's the functional group. So 2. We talk of ethanol. Ethanol. Ethanol is written as where n is equal to 1. Put the formula CA3CHO. So to the C, hydrogen here, hydrogen here, hydrogen here. Then this double bond, then hydrogen. That is ethanol. Then 3, we have propanol. Propanol. So to be where n is equal to 2. Because there's one carbon n already. So when it is 2, we say C2H5CHO. Structurally, hydrogen here, hydrogen here, hydrogen here, hydrogen here, hydrogen here. Then carbon. That's another carbon, double bond, then H. That is a propanol. 4. If you want to draw the structure of pentanol, for example, it is C5. We must start with C4. Remember? C4, then H, 2 times 4, 8 plus 1, 9. Then CH, CH2. Let's see this special C. We have one here. We have another one here. So this one will be X12 diana. Diana. That ana there is 2. So ethane diana or X12 diana. X12 diana. Ana on carbon 1, another one on carbon 2. That is what we have. So you have 6. You can have you can see 1, 2 on carbon 2. So methyl attached to carbon 2. And 1, 2, 3. So this is propanol. That's the parent chain. That is propanol. Methyl attached to carbon 2. So we say 2 methyl propanol. 2 methyl propanol. 2 methyl propanol. And so on. So this is how to name alkanol. Next something is alkanate. Alkanate. Known as ester with the functional group. The functional group of alkanates is RCOR. So it is written as R2CO2. Please take it on that. R2CO2. That's the functional group in alkanates. So let's see if it is written, if this is Or you can put methyl here, then double bond, or you can put another methyl if you like. Put another methyl. You have to name this. You always name this one first. This one is named first. So, and what you have is methyl. So we call it methyl. Methyl. That is methyl. So this one is ethanate. Ethanate. So we call it methyl ethanate. Methyl ethanate. That's the name. 2. Let's say you have 1, 2 hydrogen here, hydrogen here, hydrogen here, hydrogen here, hydrogen here. You have double bond. Hydrogen here, hydrogen here, hydrogen here, hydrogen here, hydrogen here. So if you want to name this is a ethyl. So you start with you call it ethyl. 1, 2, 3 propanoate. Call it methyl propanoate. Take note of that. That is 2. 3. Let's say you have 1, 2, 3. You have something like this. You have this 1, 2, 3. You have H, 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 H. You have H here, H here, H here, H here, H here, H here, H here. So here you start naming from here. 1, 2, 3. That is 3, 4. So for P, 1, 2, 3, 4. That is a butanoate. So P butan. All these are ester alkane. So number 4. Let's say you are giving the name. Then you have to write it down. Let's say write the structure of methyl propanoate. Methyl propanoate. You have to write the structure of methyl propanoate. So you always start from methyl, or if you start from propanoate, no problem. Propanoate, that is 3. 1, 2, 3. So you have hydrogen here. These are propanoate. You start from here. Propanoate, double bond here. Then and this is propanoate. Then methyl, the one with 1 carbon atom. That is methyl propanoate. 5. Let's say you have to draw the structure of ethyl ethanate. Ethanate. So you start from ethanate. Ethanate start from 2 carbon atom. 1, 2. Hydrogen here, hydrogen here, hydrogen here. Remember, this is double bond, single bond oxygen. Then ethyl. Ethyl is 2 carbon atom. Hydrogen, 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 hydrogen. That's how to draw the structure in the name. How to draw the structures. Number 6. Let's see propyl ethanoate. Propyl ethanoate. We must start with ethanoate. 1, 2. Hydrogen here, hydrogen here, hydrogen here, hydrogen here. Ethanoate, so double bond. You have single bond hydrogen. Then propyl, that is 1, 2, 3. 1, 2. Put hydrogen, 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 hydrogen. Take note of this. 7. Let's say you have to draw butyl ethanoate. Butyl ethanoate. So it will be ethanoate 1, 2, hydrogen, 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 double bond, single bond, then 1, 2, 3, 4. Because of boots here. So this one will be hydrogen, 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 hydrogen. What is it? So we're done with naming of carnage, that is Esther.